Hello, today I'll be going over the 2010 Form B AP Statistics problem number 5. All right, so when you look at this problem, my first glance, I see the contingency table and my mind immediately goes to independence and association. Don't get stuck, of course, in any one path until you actually read it. So let's give it a quick read. An advertising agency is conducting a survey to investigate whether there's an association, and I underlined that word association. That tells me what I thought I was going to be looking for, is that independence and that association between the different grade or the graduate levels, and then how a person gets their news, right? So between highest level of education achievement and their primary source for news, right? So we are doing what I thought. That comes up a lot when you have a contingency table. The company takes a random sample of 2,500 adults in the city. You can see that total down here. And the results are shown in the table below. Here we go. If an adult is to be selected at random from this sample, so I'm just doing a random thing, what is the probability that the selected adult is a college graduate or obtains news primarily from the internet? This word or is very important. It's not the word and, they're using that word or. Or means addition, you're putting them together. It can be either on the internet, 687, or you can have a college graduate, which is the 693. So my first instinct when I see that word or is to add things together. You do need to be careful though, because if you add 693 and 687 together, you're going to be adding this 245 twice. So I put a little arrow there to show, hey, look, when I add this row up, 245 is in the 687 already. When you add this column up, 245 is in the 693 as well. So now you're adding 245 twice, and you don't want to do that. I just want all the college graduates and all the internet users together, but I don't want to double up, right? So you add 693, you add the 687, and then you subtract the 245 for the double up, one of the double ups, right? You just don't want that in there. Okay, so that should give us our probability of this or that, right? That word or means addition. So instead of writing it out myself and wasting your time, let's go right to the scoring guide so you can see what they had written down for us. So you should be able to see here, I hope, that that's exactly what they did. 693 plus the 687 minus the 245 for the double up. That's the only reason that's there, is because the 245 is in 693 and 687 at the same time. So you got to get rid of one of those so you don't have a double up. Okay, now when you get your final answer, now these are out of the total, right? So you get 1135 out of the total 2,500, and change it to a decimal. You definitely want to do that. This is normally what they're looking for, is this decimal. You can have a fraction that's going to be acceptable most of the time, but just to be sure and to guarantee it, let's go to the decimal. You'll also notice that they have 3 decimal places. That's pretty much a standard in AP classes and AP stats for sure. You're going to want 3 decimal places. So let's write down 3 decimal places, not just 1 or 2. Okay, so it's 45.4%, right, or 0.454 is the probability that it's either one or the other, Notice up above here they're using this probability notation. You can get away with not using it on some problems, but it really is a good habit to get into, not only for this unit, but for the whole year. We're going to be using this probability notation throughout the whole year. So it is a good habit to get into. You'll see on the next problem I added it in myself because they didn't put it in, but I added it in. But let's see what that's all about. Okay, so back to here. If an adult who is a college graduate, so immediately my mind goes, who is a college graduate? So they're telling you what category you're going to look in. So this is a conditional probability. So adult who is a college graduate, so I'm going to be looking at this column only, is to be selected at random from a sample. What's the probability that the selected adult obtains news primarily from the internet? So again, of the college graduates, so only of these people, how many of them, or what's the probability is that you get their news from the internet? So the internet people are the 245 out of the 693 college graduates. So that's what they're looking for, and it's just a conditional probability. So 245 out of 693. You already know they're college graduates, so we're not looking at any other column. I'm not looking at the totals. Let's look at that back here again. So that's why I wrote this. you see this vertical line? That's how you do conditional probability. So what's the probability that a person gets their news from the internet given that they're a college graduate already? You already know they're a college graduate, then what's the probability that they get their news from the internet? Okay, this is the given bar there. And then they did the numbers. The 245 out of the total number of graduates, college graduates, 693. And again, get your decimal in 3 decimal places. 0.354, 3 decimal places. So there's your answer. Okay, part C, we're almost there. Keep in mind when you're doing a problem on AP, this should take you about 12 minutes to do this whole thing, right? About 12 minutes. So you want to briskly move along without wasting too much time, yeah? But of course, don't rush too far or you make a mistake, of course. All right, when selecting an adult at random from the sample of 2,500 adults, so you're selecting someone randomly, are the events, is a college graduate and obtains news primarily from the internet, right? Independent of each other. So they're trying to say, are these independent of each other? Does it, is there an association between your level of schooling and where you get your news source, where you get your news? Is there an association there? Does it matter, right, or not? So when you're doing independence, which is what they say here, right? We're trying to do independence. It's the same thing as association. They're interchangeable. But the idea is that, like, if I were to take this 245 for internet out of the 693, which I did in the previous problem, and I kind of recognize that when they're doing these previous problems, they're setting me up for this independence question, right? So this work that you already did will help you with the next question. And they do that quite a bit. But that probability, that 245 out of 693, should be the same or very, very close to 687 out of 2,500, right? So if I'm a college graduate and I look at the internet for news, is that the same percentage as everybody else getting using the internet as their news source? Are those percentages the same? That's what you're looking for. So let me look at that scoring guide real quick. So you're going to see here, down here is the probability that we got from the previous problem, that 0.354. I just put the fraction in again, even though we have it. And then the new fraction we need is the 687 out of 2,500. So that's this, 687 out of 2,500, right? So that percentage is 27.5%, but this, on the previous problem, we got 35.4%. These are not the same. They're not close enough. They should be almost exactly the same, like maybe 1% off, maybe 2% off, but this is way off. This is a big deal off. So right away we're going to say the probabilities are not equal. It's important that you state that, and then somewhere in here you have to state these events are not independent, right? So it says it down here too. They are not independent. Right? These categories are not independent of each other. Their percentages are different. So if you are a college graduate, you are choosing your internet, you're choosing your news source differently than everybody else. So they're not independent, they're dependent. How you choose your news depends on if you're a college graduate or not. It could be different than everybody else, based on what your education level is, right? Hopefully that makes sense. All right, and then I'm just going to quickly go through this last problem because this actually is beyond us. This is like at the end of the year, one of the last things that we do. It's like chapter 25 or something like that. But I wanted to bring it up because a lot of people say, when you're looking at these percentages on independence, they say, well, how close does it need to be? Is 1% close enough? Like if these are within 1% of each other, is 2% close enough? Is 5% close enough? Where is the cutoff where you say they're not independent anymore, or you say they are dependent or independent, right? Where's that cutoff? What percentage? How close do they need to be? Do they really need to be exact? Okay, so later on in the year, we're going to learn how to kind of judge that and say, how close are all these categories and stuff? And what it's called is called a chi-squared test. You don't need to know that now. Don't worry about it. But I think it's always important to kind of look ahead and And if that's in the back of your mind, you'll be able later to kind of match this up and say, oh yeah, like in order to find out really what's going on here, if these are really, really matched because they're really close and I can't tell, then we need to do this statistical test called a chi-squared test of association, right? And it has degrees of freedom that goes with it and all that, but you don't need to worry about that. So for now, we're not going to give you an exact answer of, oh, it has to be 2%, it has to be 5%. We're just going to say, are they the same? Or really, really close, right? Are they really, really close to being the same or not? And that's going to determine whether they're independent or not at this point, right? Later on, we can do a chi-squared test. I'm just going to show you real quick. You can see here, they call it a chi-squared test of association, and there's a way to determine the degrees of freedom, which, again, you don't have to worry about. But just know there is a way to more mathematically determine whether a set or a group like this is independent and what's really going on. And we'll look at that later. Okay, that's it.